Welcome to the session of Hungarian method. This is S.S.Nikam, Assistant Professor, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. At the end of this session, student will be able to solve the assignment problem by using Hungarian method. Now let's see introduction about this method. In assignment problem, our objective is to assign a number of origin, for example jobs, to the equal number of destinations, for example person, at a minimum cost or maximum profit. This assignment problem can be solved with the help of a method known as Hungarian method. Now let's see what is this method. Hungarian method for solving assignment problem can be explained as follows. Let an assignment problem can be given in the effectiveness matrix form. Step number 1 is subtract the minimum of each row of the effectiveness matrix from all the elements of the respective rows. Now next step 2 is now modify the resulting matrix by subtracting the minimum of each column from all the elements of the respective columns. In step 3, then draw the minimum number of horizontal and vertical lines to cover all the zeros in the resulting matrix. Let the minimum number of lines be capital N. Now there may be two possibilities. First possibility is if capital N is equal to small n, that is the number of rows or columns of given matrix, then an optimal assignment can be made. And second possibility is if capital N is less than small n, then we will proceed further. Here we will consider possibility number 1. Friends, before we proceed, let's pause your video for a minute and choose the correct alternative. The assignment problem number 1A requires that only one activity be assigned to each resource. B is a special case of transportation problem. C can be used to minimize resources. D, all of the above. I hope you have written your answer. Answer is all of the above. Now let's see example based on this method. A department head has 4 subordinates and 4 tasks have to be performed. Subordinates differ in efficiency and tasks differ in their intrinsic difficulty. Time each man would take to perform each task is given in the effectiveness matrix. How the task should be allotted to each person so as to minimize the total man hours. Now, this is the effectiveness matrix where the column indicates task A, B, C, D, and this first row indicates subordinates 1, 2, 3, 4. And this is the effectiveness matrix provided to us. Let's have solution in step number 1 as mentioned earlier. Subtracting the smallest element in each row from every element of that row, we get the reduced matrix, that is table number 1. Here in first row minimum element is 8. So subtract 8 from each element of that row, and that's why we will get new elements over here. Similarly, second row contains minimum element as 4. So let's subtract 4 from each of the respective element and we will get these new entries. Now minimum element is 15 in third row and minimum element is 10 in fourth row. We have to do the same procedure and we will get entirely new entries in table number 1. Now let's go in step number 2. Next, subtracting the smallest element in each column from every element of that column. We will get reduced matrix, that is table number 2. See the first column. In first column, minimum entry is 0. So we have to leave that column. In second column, minimum entry is 4. So subtracting 4 from respective elements, we will get new entries. In third and fourth column, minimum entries are 0. So leave those two columns. In step number 3, now test whether it is possible to make assignment using only zeros, so that it is found that minimum number of horizontal or vertical lines to cover all zeros in the resulting matrix are 4. That is, n is equal to 4, which is same as number of rows or columns. So an optimal assignment can be made. So we got some zeros, and to cover all those zeros we have to draw minimum number of possible lines. Here I have drawn 3 horizontal lines and 1 vertical line to cover these zeros. You can do this otherwise also, but the minimum possible lines are 4. In step number 3A, starting with row 1, examine the rows one by one until a row containing exactly single zero element is found. Then an experimental assignment, box or square, is marked to that cell. Now cross all other zeros in the column in which the assignment has been made. Now look at first row. In first row we have a single zero, so mark it with box. At the same time, look at the first column. If any other zero is there, cross out it. Move towards second row. In second row also we have a single zero, so mark it with box. While in case of third row we have 2 zeros, so leave that third row. Move towards fourth row. In fourth row, at the last position we have a single zero, so mark it with box. At the same time, look at the third column. We have extra zero over here, so cross out the zero. This is table number 4. Now step 3B. When the set of rows has been completely examined, start with column number 1. Examine the column one by one until a column containing exactly 1 zero is found. Then an experimental assignment, box or square, is marked to that cell. Now cross all other zeros in the row in which the assignment has been made. Now look at the first column. We have already 1 zero over here. If you see table number 4, in table number 4, column number 2 is free and column number 2 contains 0, single zero. So let's assign it. In table number 5, we will assign that 0. In next column, we have already one assigned 0. So let's move towards the last column. Already over there 1 0 is assigned. It is found that no additional assignment are possible. Thus, the complete 0 assignment is given by A goes to 1, B goes to 3, C goes to 2 and D goes to 4, as mentioned in table number 6. This is an optimal assignment for original matrix. Now we compute the minimum total man hours as follows. Optimal assignment, A goes to 1, man hours are 8. Now as mentioned in the earlier slide, this is an optimal assignment for original matrix also. We have to write down the corresponding entries of original matrix. A goes to 1 contributes 8 in original matrix. B goes to 3, 8. C goes to 2 contributes 19 and D goes to 4 is 10. So calculating total man hours, we will get total 41 hours. I have referred a textbook named Operation Research by S.D. Sharma. Thank you so much for watching this video and have a happy learning.